Hello everyone. This moment I want to share you about the how to solve this best paper. The best paper is in May, June 2018. Yeah, paper 2 AS level structure question. Okay, let me ask. Let me start from number one. Yes, number one is state what it's mean by scalar quantity and vector quantity. The scalar quantity has magnitude. Scalar quantity has magnitude only has magnitude, and vector quantity has magnitude and direction. Yeah, and direction. Yes, that's the answer is 1b. Complete figure 1.1 indicate whether it's quantity, vector, or scalars. Power, there is no direction, so this is scalar. Temperature also, there is no direction, there is also scalar. And momentum has magnitude, also direction, this is vector. Okay, see, an aircraft traveling in wind, figure 1.2, so the velocity for the aircraft is still air, and for the wind the velocity of aircraft still 95 meter second minus 1 in the west, and the velocity of wind 28 meter second minus 1 from 65 degrees south to east. Okay, on figure 1.2, draw an arrow labeled R, the direction of the resultant velocity of the aircraft. Okay, if we okay, let's say that's the magnitude is like this one. Okay. Yes, this is R. This is also something with this one. Yeah, because direction same. Okay, continue to the next number. Determine the magnitude of the resultant velocity of the aircraft. Okay, this is about the resultant vector. We have cosinus law that v square equals to from the 1 and 5 minus 2 28 25 cos this is cos, because we had this one, yeah, 150, yeah, 115 degree. So if we calculate this one, use calculator. (28) square plus 95 square minus 2 times with 28 times again with 95 times cosinus 115 degree 12.0 wait 12,000. Oh, sorry, 12,000. This is around 12,000 57.33. Yeah, so this is around, if we calculate here, is root answer. Okay, we get 109.80 meter second minus 1. Yes, this is about the resultant vector of velocity. Okay, continue the second number. State Newton first law. This is about the equilibrium. If a body continues at rest, yeah, if body continues at rest, yeah, or constant velocity, yeah, unless acted open by a resultant force. This is actually total force equals to 0 when the object in the condition is rest or constant speed. So question B. A block weight 15 Newton hangs by wire from a remotely controlled aircraft as shown in the figure 2.1. The aircraft is used to move the block only in the vertical direction. The force on the block due to air resistance is negligible. The variation with time t of the vertical velocity v of the block is shown in figure 2.2. The velocity is taken to be positive in the upward direction. Okay, this is the graph about the aircraft motion on the block weight 15 Newton. Yes, start from negative 7 meter per second, yeah, then going down until 0, yeah, and then up again until around 3 point something. Yes, actually this is about the, I think this is going down until 0 and then up, because the direction is from the negative, yeah, to 0 and back, go up. Okay, let's find the questions are. Determine for blocks the displacement time t from 0 to 3.0 second. Okay, actually the distance is area of the this graph, yeah, from O until 2, from O until 2 second. We see here this is around a half of 2, yeah, displacement is a half of 2, yeah, this is around This is 6.8. Yeah, this is around 6.8. Sorry, this is around 6.8, and we get the, this is 6.8, and we get 6.8 meter. Yes, this is the distance first, yeah, from 0 until 2 seconds, but after 2 seconds we have until 3 seconds. This is wrong. Here it's let's say this is about three second, 2 second is 1 second actually, yeah. And here is let's say this one 3.4. Yeah, this is 3.4. Yeah, this is 3.4. So we have D2 is or half 1 times 3.4. So we have 1.7 meter. So if they plus it, this is around, total distance is 8.5 meter. Yes, 8.5 meter. Yeah. Oh, sorry, this is distance. Yeah, the question is displacement. So the displacement is, this is distance. The displacement is 6.8 minus 1.7, so we have 5.1 meter. Yeah, the displacement. Yes. Okay, question 2. The change gravitational potential energy from time O until 3 seconds. Okay, this is about the change energy, because we have the distance or displacement. Sorry. So delta potential energy equals to mgh, but mg we already know, but 15, and h is equal to displacement, so we get times with 5.1. so we have 15 times 5.1 equals, sorry, 15 times 5.1, 76.5 joules. 76.5 joules. Yes, this is the potential energy gain this object. So question II, calculate the magnetic acceleration of the block at the time 2.0 second. At the time 2.0 second, we have, this is about delta V per delta T. A equals to dV per dt. So we have start at time 2 second, we have, let's say this is 2 second, and V ops, I think, because this is graph, this is about distance. Yeah, so distance over time. This is about the slope or gradient. So the gradient is if we see, this is about the actually 3.4 divided by 1. Yeah, this is 3.4 divided by 1. This is around 3.4 meter second minus 1. Yes. Okay, and question III, use your answer B2, yeah, BII, to show the tension T, the wire at T2.2 second is 20 Newton. Okay, this is about the Newton's law. Here, that's if the object who have weight and tension group, and this is total force equals to ma, and this is going up, so tension minus W equals to ma. Tension minus 15 and mass equals to weight divided by gravitational acceleration times A is 3.4. So we have tension minus 15 equals weight. We calculate first the 15 times with 3.4 divided by 9.81. Yes, this is around 5.198. Yeah, so we plus with 15 the tension group around, yes, 20 Newton. Yes, around 20 Newton. So finally we get the answer question from this number. So the question other question is about modulus Young. The wire has cross-sectional, this is the area, and the metal Young modulus 1.7 times 10 to the power 11 Pascal. The wire obeys Hooke's law. We calculate the strain wire at time 2 seconds. Okay, this is about the tension group. Modulus Young as the force over A L delta L. Okay, strain sorry, this is strain. The questions about delta L over L, so we have this is force over EA. Yes, then we have force about 20 Newton, yeah, tension group, and then E equals to 1.7 times 1011 times with A equals to 2.8 times minus 5. So we have let's say we calculate this 120 divided by 1.7 divided by 2.8 equals it with 4.20 times with 10 to the power, this is 6, that is minus 6. Stress, there is no unit here, there is no unit, so we get this is around, yes, 4.2 times minus 6. Okay, continue to the next number, to the next question. At the sum of 33 seconds, the tension in the wire has constant value is 15 Newton. State the explain whether possible deduce this block moving vertically at time 3.0 second. If the tension group 15 Newton, so we have W or weight equals to 15 Newton, so there is no resultant force here, no resultant force, so this is constant speed or constant velocity. Yes, the resultant of force equals to 0. Okay, continue to number 3. Number 3 is state what it's mean by mass of a body. Wow. Mass is property or body of object resisting change in motion. Yeah. Actually, the mass is quantity. Yeah, is the quantity of matter. Yes, quantity of matter in a body. Yeah, in a body. Okay, I think that's best answer, I think. So B, two blocks travel directly toward each other along a horizontal frictionless surface. The block collide as illustration in figure 3.1. Yes, 3m has velocity 0.4 meter second, and m has 0.25 with opposite direction. Block B, block A, and this is after collision, after collide. They have for 3m, they have 0.2 meter second minus 1, and m has velocity v. So use the Newton third law, explain why during the collision, yeah, the change in momentum of block A is equal and opposite to change in momentum of block B. Why? This is about force on A by B. Yeah, force on A. This is by B. Yeah. Equal and opposite. Yeah, equal and opposite. Equal and opposite to force. Yeah, to force on B. Yeah, to force on B by A. Yeah, opposite on B by A, or both A and B. Yeah, A and B exert equal and opposite force on each other. Force on each other. And force is rate of change. Force is rate of change momentum, and time, yeah, is of contact. Yeah, of contact is sim. Yes, because this is the approaching of the Newton third law. Yeah. Okay, question II. This is about determine speed v. Okay, this is about the momentum conserve. Yeah. Momentum conserve about this 3m times with 0 for O, yeah, plus m minus 0.25 equals with 3m after collide. They have 0.2 on the positive direction, and plus mass m times v. So we can cancel it about m. Yeah. So we have 3m. This is 1.2. Oh, sorry, this is minus. Yeah, minus 0.25, yeah, equals to 0.6 plus v. So we have v equals to 1.2 minus 1.2 minus 0.25 and minus 0.6. Okay, we have 0.35 meter second minus 1. Yes, this is the answer of mass M. Continue with velocity v 0.35 meter second. Continue to the next question, still on the number 2. Calculate for the blocks the relative speed of approach. This relative speed of approach, this is because 0.4, yeah, start from 0.4, yeah, and plus 0.25, yeah, this is about the velocity. This is around 0.65, yes, meter second minus 1. The relative speed approach between mass 3m and mass m, yeah. So the relative speed of separation, this is we see this is around v is 0.35 and 0.2, 0.35 minus 0.2, and we have 0.15 meter minus second. Okay, we can see on the relative speed of approach and the relative speed of separation. Yeah, this is before collide and this is after collide. Use your answer B33 to state and explain whether the collision is elastic or inelastic. So if we see this is because different velocity, so the answer is non-elastic, or the collision is inelastic, yeah, because different velocity, yeah, approach and separation. Okay, continue to the number 3. Oh, this is about the number 4. This is about the width. Number 4 is for a progressive wave, state with what it's meant by period. Okay, the period is time for one oscillation, yeah, time one oscillation, time for one oscillation, yeah, or time one wave, yeah, one vibration or one vibration or one circle. So wavelength about the length of, yeah, length of distance of, yeah, this is distance between wave front, yeah, yeah, or distance one wave, distance one wave. Okay, continue to the next number B. So the variation of time t of the displacement x of two progressive waves P and Q passing the same point. The speed of the wave is 20 centimeter second minus 1. Yeah. So the question is calculate wavelength of the wave. by using the formula that V equals to lambda frequency or lambda divided by period, so we have period and V, so lambda equals to V times period. V is 20 centimeter per second. Then period, if we see, this is like around 0 to 0.6, yeah, or this is coming from 0.6 also, 0.6, so this is about 12 centimeter. This is the wavelength, yeah. So other question, determine the phase difference between the two waves. Phase difference, this is around of yes, if we see, this is until here to here, this I see oh, when they come 0.2, oh, this is 0.2, this is different between here. This is around 0.2, 0.2 divided 0.6 times with 2 pi, so we have, this is 2 pi or a third of 360, this is around 1 to 0 degree, yes, 1 to 0 degree phase change. Okay, calculate the ratio intensity of Q and P. The intensity is proportional with A square. So if we see the A, Q and P, yeah, this is, let's say this is about the IQ, IP, this is around IQ, IP square. So if we see Q and P, Q, with Q have 2 millimeter and P have 3 millimeter, so we have square, this is around 4 divided by 9, or the ratio IP IQ, the ratio IP is equal to 4 ratio with 9. Okay, this is the answer. Okay, continue to next number. The two waves superpose as they pass at the same point. Use figure 4.1 to determine the resultant displacement at 0.045. The displacement is, if we see 0.45, this is 5, yeah. Maybe like this one, displacement of time, oh, this is around 1 and this is around 3. Yes, this is around 1 minus 3. Yeah, this is around minus 2, actually 2.00, yeah, minus 2.00 millimeter. Okay, continue to the next number. Yes, number 5. When monochromatic light incident normally at the diffraction grating, the emergent light wave have been diffracted and are coherent. Explain what it's meant by diffracted wave and coherent wave. Okay, diffracted wave is wave spread at its light. Okay, this is wave. We call it a spread. Yeah, spread at each gap of each slit. So what the coherent is? Coherent is phase difference between each. Coherent is phase differences. Yeah, phase differences between each of wave. Yes, phase difference between each of waves. Okay, question B. Light consisting on only two wavelengths lambda 1 and lambda 2 is incident normally on the diffraction grating. The third order diffraction maximum of the light of wavelength lambda 1. The fourth order diffraction maximum light on the lambda 2 at the same angle theta to the direction of the incident light. So that ratio lambda 2 divided lambda 1 equals to 0.75. Okay, if you know this is about n lambda equals to d sine theta. So if we see the lambda 2 divided by lambda 1, this is opposite with n, and 1 divided by n2. So this is n1 is third and n2 is fourth. So the same thing, 0.75. Yes, correct. So question II. The differences between two wavelengths is 170 nanometer. Determine wavelength lambda 1. Okay, this is lambda 2. We only use this one. Lambda 2 is 170 nanometer divided lambda 1 equals to 0.75. So lambda 1 equals to 170 divided by 0.75. So we have 2226 2226.66 nanometer. That's the answer is. Okay, continue to the other number. Calculate know about the number 6, about the electricity. Define volt. Yes, volt is about the energy per charge. The potential difference volt is joule per coulomb. Yes, joule per coulomb. Then B. Question B. A battery of electromotive force EMF 4.5 volt and negligible internal resistance is connected to two filament lamps P and Q and a resistor R as shown in figure 6.1. Yes, The current in lamp P is 0.15 ampere. Yeah. The IV characteristics of the flame lamp also figure 6.2. Yes, this is figure 6.2. The X is volt, the Y is ampere current. Use the figure 6.2 to determine the current in the battery. Explain your working. Wow. We use the graph to find the current. Yeah. P and Q. Okay. Current on the battery equals to current on the earth. Yeah. So this is equals to current on the P and Q. So current total, this meaning equals to I on P plus I on Q. So if we see the voltage on the resistor, the current lamp P is 0.15 ampere. IP, wait. Oh, this is 0.15 ampere plus, but IQ, wait, this is about 0.0. Use the figure 6.2. Okay, let's say we see IQ on the when I is 0.15 IP. Oh, here, yes, then here, oh, 0.09. Yes, yeah, in the same line. Yeah, so we have this is 0.24 ampere. Okay, we get it. Continue to the next number, R. Calculate the resistor of R. The resistor of R. You see about the Ohm's law. Yeah. The R equals to potential on the parallel one divided by I. So potential on that, we get this is 4.5 and minus 2.7. This is the potential on the lamp divided 0.24. so we have 4.5 minus 2.7 divided by 0.24. Yes, 7.5 ohms. Yes, this is the resistor. Okay, then continue to the next number. The filament wires of two lamps are made from material with the same resistivity, okay, at the their operating temperature on the circuit. The diameter of the wire lamp P is twice the diameter P is twice the diameter of the lamp Q. Okay, determine the ratio length of the filament wire of lamp P and Q. Okay, because the resistor of the P and Q filament lamp P and Q, wait, this is about the wait. Oh, I see. RP RQ, this is about VP, V divided I on P, V divided I on Q. So we have the R equals to 2.7 divided by I. P is 0.15, and 2.5 divided by 0.09, so this is equal to 0.09 divided by 10, about the ratio of R. So if we calculate this, 0.09 divided by 0.15, so we have 0.6. This is ratio of resistor P and Q. So because this is related diameter, so we have contribute by R equals to rho LA. Yeah, resistivity is same, but diameter is in A. So length, yeah, if we see the ratio, this is about the oh, let's see this number 2. So we have the ratio is the ratio of length P and Q. This is same thing with 0.6 with this is 2 square. Because why 2 square? Because the A equals to PR square, then 0.6 times 4, this is around 2.4. Yes, the ratio is 2.4. Okay, continue to next question. The filament wire of lamp Q breaks and stop conducting. Wow. State and explain quantitatively the effect on the resistance of the lamp P. So because the resistor in the parallel is smaller than they individually, so is it about the less potential difference, yeah, across resistance, yeah, or greater on P, yeah, potential difference on P lamp, yeah. Greater current through P, yeah, greater current on P, yeah, because resistance down and resistance P increase, and resistance in P increase. Yes. Okay, continue. Final question number 7. This is about the radioactive. A beta negative particle from radioactive source in traveling in vacuum with kinetic energy 460 electron volt. The particle enters a uniform electric field and right angle that follows the path shown in figure 7.1. Kinetic energy 460 electron volt. This is path of beta particle. Sorry. Question A is the direction of electric field in the plane of the paper. On figure 7.5, draw so direction of the electric field. So because the particle, this is negative, yeah, so this is positive. This is negative, yeah. It means the electric field it's become down, yeah, from positive to negative. Okay. B. Calculate the speed of beta particle before it enter electric field. Okay, this is about the kinetic energy equals to electric particle kinetic energy. So we have kinetic energy equals to a half mv square. This is 4 6 electron volt is 1.-19 to convert to joules, and equals to a half mass is mass of beta equals with 9.11, yeah, times -31 v square. So if we calculate this number from 460 times speed 1.6 equals times 2 divided by 9.11. Yes.
Ujian ya? Ujian level, as level?
Iya. Oh. Iya, Pak. 161 v square equals 161 0.58 time minus 31 minus 90 12. This is around 12, so we have root of 161.58 12.7 1 time 6 or 1.27 times with 5 meter second minus 1. Okay, the final question is other beta negative particle from the same radioactive source travel outside the electric field along the same incident path as the shown in figure 7.1. State the briefly explain whether those beta negative particles will all follow the same path inside the electric field. A beta negative particle actually they have range yeah, of different or various speed, yeah. or velocity or moments or velocity or moments or energies. Yeah. So so they follow different path. They will follow different path. Okay, I think the best answer for this question. Okay, finally we done the answer all this question. Thank you very much for watching my video. Don't forget to subscribe my video, like or comment, or thank you for your sharing to other student. Yeah, share on my channel. Thank you very much. Thank you. Bye bye.